Welcome to this comprehensive guide on the publisher-subscriber or pub/sub model, a fundamental design pattern in modern software architecture. This pattern is essential for building scalable and flexible applications, allowing different parts of your system to communicate efficiently without tight coupling. This pattern enables components to communicate without direct connections, fostering flexibility and maintainability in your applications. By decoupling the sender from the receiver, the pub/sub model significantly reduces dependencies, making your software easier to develop, test, and evolve over time. At its core, the pub/sub model involves publishers who send messages and subscribers who receive them, all facilitated by a central channel or topic. This central mechanism acts as an intermediary, ensuring that messages from publishers reach all interested subscribers without direct knowledge of each other. Let's break down the key concepts. The publisher is the component that initiates and sends messages to a specific channel or topic. Publishers are responsible for generating data or events and broadcasting them to the system, without needing to know who will consume them. The subscriber is the component that expresses interest in specific topics and actively listens for and receives those messages. Subscribers define what kind of information they want to receive, and the pub/sub system ensures they get only the relevant messages. Messages are the actual data transmitted from the publisher to the subscribers, carrying the information needed for communication. These messages can be anything from simple notifications to complex data structures, depending on the application's requirements. The channel or topic acts as the pathway, a named conduit through which publishers send messages and subscribers receive them. It's the central point of communication, allowing multiple publishers to send to the same topic and multiple subscribers to listen to it. Finally, a message broker is an optional but often crucial intermediary that efficiently routes messages from publishers to their interested subscribers. The broker handles message queuing, persistence, and delivery, adding robustness and reliability to the system. The pub/sub pattern offers significant benefits, starting with enhanced decoupling, making your code more flexible and easier to maintain. This separation of concerns means that changes in one component are less likely to impact others, simplifying development and reducing bugs. It also provides excellent scalability, allowing you to add more publishers or subscribers without major system overhauls. As your application grows, the pub/sub model can easily accommodate increased message traffic and a larger number of interacting components. Flexibility is another key advantage, as subscribers can dynamically join or leave topics as needed, adapting to changing requirements. This dynamic nature allows for highly adaptable systems that can respond to varying workloads and user demands. Asynchronous communication ensures that messages are sent and received without blocking the execution of either the publisher or the subscriber. This non-blocking nature improves application responsiveness and overall performance, especially in distributed systems. Increased scalability allows systems to manage large volumes of messages and users without overloading individual components. By distributing the workload, the pub/sub pattern helps prevent bottlenecks and ensures smooth operation even under heavy load. Reliability is built in, with features like message durability, retries, and acknowledgements ensuring dependable communication. These mechanisms guarantee that messages are not lost and are processed correctly, even in the face of temporary network issues or component failures. Now, let's dive into implementing the pub/sub pattern in Visual Studio using C#, leveraging delegates and events. This practical demonstration will show you how to set up a basic pub/sub system within a familiar development environment. First, we define a delegate, which is a type representing a reference to a method crucial for event handling. This delegate acts as a contract, specifying the signature of the methods that can be subscribed to our event. Next, we create a publisher class. This class will manage the publishing of messages through an event. The event declared within this class will be the mechanism through which subscribers receive notifications. Then, we implement the subscriber class. This class will subscribe to the publisher's event and handle incoming messages. When the publisher raises an event, the handle message method in our subscriber will be invoked, processing the received information. Finally, we demonstrate the usage. We instantiate the publisher and 2 subscribers, then publish a message. This setup illustrates how a single message from the publisher is efficiently delivered to multiple interested subscribers. This simple example illustrates how messages are sent from the publisher and received by all subscribed entities. It highlights the fundamental interaction between publishers and subscribers using C# events and delegates. Now, let's explore implementing the pub/sub pattern within the Unity 3D engine, creating a simple event system for game components. This will demonstrate how the same principles can be applied in a game development context to manage interactions between game objects. First, we create a publisher class in Unity, responsible for raising events that other components can listen to. This class will define a static event, making it accessible globally for any subscriber to attach to. Next, we create a subscriber class. This script will listen for the events raised by our publisher. It will subscribe to the publisher's event in its onEnable method and unsubscribe in onDisable to prevent memory leaks and ensure proper event handling. To use this, attach the publisher script to an object that will raise the event and the subscriber script to objects that need to respond. This setup allows for flexible communication between different game entities without direct references. When raisEvent is called on the publisher, the handleEvent method in the subscriber will execute, demonstrating the communication. This shows how game logic can be decoupled, allowing for more modular and manageable game development. Now, let's cover some helpful tips and best practices for working with the publisher-subscriber pattern. Adhering to these guidelines will help you build more robust, efficient, and maintainable pub/sub systems. First, use interfaces for publishers and subscribers to further enhance decoupling and improve testability of your components. Interfaces define a contract, allowing you to swap out implementations without affecting the rest of your system. Implement message filtering to allow subscribers to receive only the messages that are truly relevant to their specific functions. This reduces unnecessary processing and improves the efficiency of your subscribers. Always include robust error handling to gracefully manage any potential issues that might arise during message delivery. This includes mechanisms for retries, dead letter queues, and logging to ensure system stability. Utilize asynchronous processing to prevent blocking the main thread, which is especially critical in performance-sensitive applications like games. Asynchronous operations ensure that your application remains responsive while handling messages. Write comprehensive unit tests to ensure your pub/sub implementation functions correctly and reliably under various conditions. Thorough testing helps validate the message flow and the behavior of both publishers and subscribers. Consider leveraging existing messaging products and services like Azure Service Bus, Event Hubs, or Event Grid for robust solutions. These managed services provide advanced features like message persistence, scaling, and security, reducing development overhead. Design your system to ensure message processing is idempotent, eliminating any dependency on the order of message handling. Idempotent operations can be safely retried multiple times without causing unintended side effects, enhancing reliability. Employ dependency injection to register publishers and create them only when they are truly needed, particularly in web applications. This promotes loose coupling and makes your application more modular and testable. In Unity, consider using the singleton pattern to ensure you always work with the same instance of your publisher class. This can simplify event management and ensure that all subscribers are listening to the correct publisher instance. Finally, an event aggregator can serve as a central hub to aggregate all published messages and efficiently dispatch them to interested subscribers. This pattern can further simplify communication in complex applications by centralizing event management. The publisher-subscriber model is a powerful tool for building scalable, flexible, and maintainable software systems. Its ability to decouple components and facilitate asynchronous communication makes it invaluable for modern application development. By understanding and applying these principles, you can significantly improve the architecture of your applications. Embracing the pub/sub pattern will lead to more robust, adaptable, and easier to manage software solutions. Thank you for watching this training video. We hope this guide helps you master the publisher-subscriber pattern and apply it effectively in your own projects. Continue exploring and building with confidence.